14, a new 300 megawatt solar power plant is proposed to be built in Broken Hill, requiring a new 1,200 kilometre transmission line to connect to the New South Wales electricity grid. Due to the immense distances, electricity will be transported at extremely high voltages of 500 kilovolts with transmission line resistance of 0.001 ohms per metre. Now, the first part of the question asks you to explain why modern grid electricity transmission is both alternating in current, in form, and extremely high voltage. Okay, so DC current cannot be easily transformed up and down in terms of voltages. So because AC can be transformed into high voltages using a transformer, we use AC. And this kind of leads on to the next part. The high voltage allows us to reduce the power losses. So put simply, one, AC can be easily transformed. We can use transformers to step up voltages, and then we send it over the power lines, send it a long distance, and then when we bring it down, we have substations that bring down that voltage again to a usable voltage for our homes. And we can do this with transformers. Now, the second part of this is, why do we want to increase the voltage? That is because of the power loss of electricity as it goes through wires. If you recall the formula, the current squared times the resistance is what determines how much power loss we're going to have. Now, really high currents are going to lead to lots of heat generation in the wires as well. But more importantly, we're going to actually lose a lot of that power if we have high currents. So based on Ohm's law, V equals IR, if we increase the voltage, then the relative current can drop. So we can send the same amount of power. Remember, if P equals IV, our power, if we increase the voltage, the current can drop. Okay? So that's why we want to send things at really high voltage, and that's why we use AC, because we can do this using transformers. Now, the second part of this question is, determine the total transmission losses through the transmission line in watts. Okay, so that's our first question. And our second one over here, we have. So first of all, let's think about what we have in this question. Determine the total transmission losses through the transmission line in watts. Now, in this question, it says 1,200 kilometers of transmission line. So that kind of gives me a clue that I'm going to need to find the resistance, the total resistance of this transmission line. So let's find that first. So the total resistance is simply 1,200 kilometers. So we're going to turn that into meters, multiplied by 0.001 ohms. And that's simply because we have 1,200 kilometers multiplied by 0.001 ohms per meter. So if I multiply this out, put a meter there, we get 1,200 ohms. All right, so we know the resistance in the circuit from the grid to wherever it is we're going. What else do we know? We also know the voltage and we know the power. Okay, so it says we're using a single line. What is the current? That's what I want to find out. But if I know the power equals IV, and I know that the power is 30 megawatts, equals current times 500 kilovolts. Now, it's important to consider the units here, so I might just write them out so we don't get too confused. Watts equals current times 500 volts. Makes it a bit simpler, and therefore I know that the current flowing through these wires is 60 amps. Okay? If we've got 60 amps here, what we really need to know is how much are we losing in these wires? Remember this formula here? That's what we're going to refer to. So the power loss in transmission lines is current squared multiplied by R. And that gives us 60 squared times 1200. And therefore we get, what is my value? We have 4,320 or 4.3 million, 20,000 watts, or 4.32 megawatts. Now, this could be a realistic case because when we have long transmission lines, if we're sending 30 megawatts of power, we might expect to lose 10 to 15%, which is the case we have here. Obviously, you could increase the voltage even higher, and that would reduce the currents, and which would drastically reduce the losses as well. Okay, that's that question there.